Hey everyone, welcome to another Open Cluster Management Community Meetings. Today is the August the 4th. Today we have Wei Liu and Long Long Tao gonna talk about the event-based manifest work enhancement proposal. I'm not sure who's gonna share the screen. Wei Liu, Long Long, please take it away. Thank you.
Yeah, okay, thank you. I think I will share my screen. Um, First, I think I will go through the enhancement, and then Dong will share a demo for this enhancement. Yeah, would you see my?
Yes.
Yeah, okay. Okay, let's go through the enhancement. And in this enhancement, we introduce the event-based manifest work. And with the event-based manifest work, we allow harbor controllers like the add-on manager or manifest work replica set controller distribute the manifest workers as event messages. Because we use the event-based manifest work, so we can model store them in the hub cluster etcd. And for manage the cluster work agent, the agent subscribes to the manifest works. It also can evolve to store the manifest work in the managed cluster etcd, so that we can optimize the scale issue when we meet a large of manifest works. And on the other hand, with the event-based mechanism, we decouple the hub controllers and work agent, so that we can allow other architectures such as non-Kubernetes RESTful service with database to consumer manifest workers. And moreover, uh, in edge computer scenario, the event driver approach allows manifest works to be efficiently distributed and applied to the edge clusters. I think this is our motivation, and we also define some terminology. There are three. There are three terminology. One is source. The source is a component. It can be a controller on the hub cluster or a RESTful service handle the resource request. For example, a user request to deploy resource on the managed cluster from source. And the other is the work agent. It subscribes the manifest work from the broker and get the source from the event and deploy the source on the managed cluster. And the broker is the message broker that handle the event transfer between the source and the work agent. It can be a MQTT broker or a Kafka broker, and also it maybe can AMQ broker and so on. In this enhancement, our goal is to give event protocol for delivering for deliver manifest works and return the status information. And we also defined a resync mechanism to for the resource. And we also provide a client for developer. The developer can use this client to build their source or work agent easily. And our and in this enhancement, we don't define how to implement a source, or we do not any assumption for the broker. For example, we don't define how to storage and how and persistent the message. Yeah, and uh, and in our design, we mainly include three parts. One is spec and status event, and the other is the spec and state resync mechanism, and the last is the client interface. So I think we can go through the spec event firstly. And the spec event is for the source and the spec event to uh, source use the spec event to send their resource to the message broker, and the work agent will subscribe the spec event, and then get the resource from the spec event. Then the work agent will deploy the resource on the managed cluster. Here is the event transfer flow. We can go through it. Okay. Firstly, the work agent will subscribe the spec topic on from a broker, and the source received a request. It will encode the it will encode the resource uh, to a cloud event and publish the event to this spec to this topic, and then the work agent will receive the event. Then the work agent decode the spec event and get the resource from the spec event, and then it will deploy the resource on the managed cluster. Yeah, this is the spec event transfer flow. And for event part, we include three parts. One is the context attributes. We define the source ID and the event type here. The source ID indicates one source. It may be for hub controller, it may be the hub hash and the controller name, and for other service like the RESTful service, it may be have maybe the name of the service. We need a unique ID here. And the type is indicated and the type is the cloud events type. It indicates the message, the event message type. Its format is the group of the resource version, and resource name. And it also includes sub-resource. The sub-resource can be spec or status. And also we can define the action here. For example, the create request, update request, and so on. And the other part is the extension attributes. It includes the resource ID, resource version, and the deletion time step, and the cluster name. The resource ID is uh, uh, the resource ID is a unique ID for this resource, and the resource version increase the number for this resource. This means when we update the spec, the resource version will be increased. And the deletion timestamp is used to mark the resource will be deleted from the source. So the work agent once finds find this timestamp, it will delete the resource from the managed cluster. And the cluster name indicates the resource will be deployed to which cluster. Yeah, this is the extension attributes. And the last part is the payload. Currently, we support two format payloads. One is manifest. It includes a single resource. For example, here we can write a Kubernetes deployment here, and the other is the manifest bundle. It same as our manifest worker definition. Yeah, this is the spec event the schema. And here we have an example for this. So firstly, the hub controller send the event to the spec topic with its source ID, and it indicates the managed cluster. And here we can go to the payload. It defines a deployment on the event message in the event message. And for the update resource, because the spec is changed, so the resource version is increased. And here we modify the deployment specs. And the last example is delete a resource. For delete action, the source add the deletion time step. It indicates the resource will be deleted from the source. Yeah, this example is for the manifest bundle. We can see the payload is same as our manifest work. It includes the manifestors and also have the manifest configures. Here we can set the feedback rules for the resource. And also this example is for the update resource. It's same as the update one single manifest. Here also we need to specify the resource version. We need to increase the resource version here. This is the deletion this is a deletion resource. It similates the previous deletion actions. Yeah, I think this is all for the spec event. And next we will go through the status event. The status event is used when a source publish a resource to the work agent deploy the resource on the managed cluster. Then the work agent will send the resource status back to the source. Yeah, we can go through the event transfer flow here. So for source, it firstly it subscribe the topic, the status topic, and it need to specify its source ID. And because the source will uh, 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 because the source may publish the resource for multiple clusters. So here is the world card. And for work agent, when the work agent uh, uh, receive the spec and receive a spec event and deploy the resource from the spec event on the managed cluster, it will get the resource status. Then it publish the status event to the broker in this topic, and when the source received the status event, it decoded the status from the event and and handle the status in the source. Yeah, here is the status event scammer. It also includes three parts. One is the context attribute. The other is the extensions, and the last is the payload. And for the context attribute, it same as the spec context attribute. It also have the source tab. And for the extension part, it also need the resource ID and the resource version and the class name. Here the class name is the agent class name. It indicates the resource status from which cluster. And the payload will also have two formats. One is for the manifest, and one is for the manifest bundle. And for the manifest, it's a single resource, so it has the reconcile status. It represents the reconcile status of the resource deployed on the managed cluster. And also it have the resource meta. It include the resource group version, kind, name, and namespace to indicate which resource. And also it has the content status. It represents the condition of this resource on the managed clusters. And for the manifest bundle, it same with as Manifestwork status. It also have the condition and the resource stations. Yeah, here is the example. The first example is report a single resource. If the event format is a manifest, it report the manifest status back. Firstly, the work agent send the state with the cloud event to the status topic. And here it add the resource ID and the resource version. And he set the reconcile status because it applied the resource and the resource is available. And also have the resource meta. It indicate the which resource. For this example, is a deployment and name and namespace. And also it replace the and send back the deployment status. And for the manifest bundle, it's same as the manifest. The different is the event is the event payload. This payload is this payload is for the manifest work. We can see the condition and the resource status here. Yeah, I think this part is about the status event schema and transfer flow. And next we will go through the resync part. The resync part also have the resync part includes the spec resync and the state resync. I think we can go through the event transfer flow. Firstly, for the spec resync, it triggered from the work agent part. This because this happened when work agent restart. All work agent have some errors. Uh, it restart and it need it need request the spec to resync its spec. So firstly, the source subscription the spec resync request topic, and when the work agent start, he subscription the spec topic. This topic is used to receive the spec event, and once the work agent start, it publish the resync request to the broker, and when the source receive this event, it publish the spec. It publish its spec to the broker, and the work agent will receive the specs and sync its spec on the work agent. And here is I think here is some details. When the work agent send resync send spec resync event, the source receive the spec resync event. The source uh, uh, will determine which spec will be returned to the work agent. It will follow uh, follow 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 these conditions. So if the request event message is empty, the resource returns all resource associated with this work agent. And if the request event message contains the resource ID and versions, the source will retrieve the resource with the resource ID and compares the version. And if the request resource version matches the resource current maintained resource version, the source will not resend the spec again. And if the resource is older than the source current maintained resource version, the source will send the resource spec event. So for these two conditions, it will reduce the spec message between the source and the work agent. Yeah, as next we can see uh, the spec resync event schema. It It also includes two parts. One is the context attribute, and the other is the payload. For the payload part, we have the resource variance. It's a list. It includes the resource ID and the resource variant, which is in the work agent, maintained by the work agent. Yeah. And next, I think the status resync. Also, we can go through the event transfer flow first. The status resync is triggered from the source. Source requests the work agent to resync the status in the source. So firstly, the work agent will subscription the status resync request, and the source when the source is start, it will subscription the status topic to receive the status from the work agent, and then it will publish a state resync event to the status resync request topic. And when the work agent received this topic, and when the work agent receives this message, it will compare the status hash in the event message and send the status back to the source. The source received the status and resync the status on the source. Yeah, here also have some details how to send the status. So if the event, if the source status request event payload is empty, the work agent returns the status of all resource it maintains. And if the source status resync event payload is not empty, the work agent retrieve the source with the resource ID and compares the received source status hash with the current resource status hash. If the hash is not equal, the work agent will resend the resource status message. So with this condition, this will also help to us to reduce the status message. And here is the status request event scammer. It's sent by the source. So it includes two parts. One is the country context attributes, and the other part is the request data. It also the data is the state hash list. The state hash include the resource ID and the status hash. This hash is calculated by the source. The source may retrieve the status from its database or etcd and calculate the status hash and set this. Yeah, I think it's the status resync request event scammer. And next part is the client. We provide a generic based client implementation to publish subscription or resync resource objects between the source and the agent with the cloud event. We can say this client has we can say this client's interface, it has three functions. One is resync, one is publish, one is the subscript. Uh, and also we require the resource object should have some methods, should have some functions. For example, for the resource object, it should have the get UID. This is return the resource ID, and also it have a method for to get the resource version, and also it need a get delete time, the deletion time step to mark its deletion or not. Also, we need a set deletion time step. For example, when we do resync, we may delete the resource delete the resource from the source. That resource is not exist in the agent. And also we need the resource object provide its codec. With this interface, we can decode the event to the resource object, and we also can encode the resource object to the cloud event. And also we need this resource object provide the hash getter. We can use this hash getter to calculate the resource object status hash for the status resync. And at last, we need a lister to list the object. This also is for the resync part. So here is an example for developers. Developers can we also provide an implementation for this interface. So the developer can use our implementation to easily create their client for their resource. For example, they can easily to build a client for Manifestwork. Here we can see he specified the cloud event clients. It's based on MQTT, and also it provides the Manifestwork list and the Manifestwork state hash getter. And also the developers add its decoder and encoder for its cloud event format. Here we support the manifest bundle and the manifest. And also we also provide a work client builder for developers. The work client based on the cloud event client. It supports to use event to deliver the manifest work. So with this work client, the developer can easily can easily integrate uh, uh, with their controllers. For example, the developers can easily create the Kubernetes and lister, and for their controllers, they don't need to modify uh, their logics. Yeah, I think this is the client part. So I think that's all for the enhancement. Any suggestions or questions? Or we can do the demo firstly, then we discuss this later. No, do you want to do the demo?
Let me share my screen.
Okay.
I think you, okay. Can you see my screen?
Yes, we can.
Okay, let me give a quick demo for what we have done. So firstly, I want to, as Liu mentioned that we have mainly two kinds of songs. So I will demo both songs and mainly focus on two kinds of cloud events we will send to the work agent. So in this demo, I set up two kind of cluster, and in cluster named hub, we deploy the MQTT broker and also the hub controller as a source. And also in the hub kite cluster named cluster one, we deploy the work agent. And we also have another source. This source is a RESTful API and plus with a database. And we will run this outside the cluster as a process, but it can connect it to the MQTT broker. So first thing is a demo. I want to show how to use a REST API to send a cloud message. This and to the work agent. So I will create a cloud event that wrapper Ajax deployment through the REST API. And then you can see that this is a sounds logs, and it will send a spec create request this type. Since this sounds will include a single response event, so the type is with keyword manifest. And in the payload, as you can see, it's just a Ajax deployment. And the resource ID and resource version, as Liu mentioned, it's just the resource ID, UUID for the resource. And since we just created the resource, it's a resource version, it's just one. And for the work agent, it will receive this event. Receive this event, it's just similar to the event is sent from the source. And then decode this event and apply the results to the class one. And after the results is, in this example, it just Nginx deployment is ready. It will send back to the source the status report. As you can see, in the status report cloud event, the type is status update request. And the resource ID and resource version is just the one in the spec create request. And in the payload, we have three parts. The first part is reconcile status. It means that the result is greater, not in the cluster. And also the resource meta to track which returns were created. And also the containers contain status is just the status from the created results. Here is just the status for the Nginx deployment. And we can also update these results. This time I want to firstly get the results ID we just created is the results ID. And then we want to create a new deployment. We want to update the Nginx deployment from replica 1 to 3. And then we create another request. And as you can see, it will send a new cloud event. Here, as you can see that it sent another request and still is a single results cloud event. But this time the results version is changed to 2 because we changed the replica of the Nginx deployment from 1 to 3. And then the work agent will receive the request and then send back the status. And in this status, the results version is also changed. And reconcile status is also the same as with new observation generation, and then results meta is still the same. But in the contain status, we can see that the available replica is changed to 3. We can also check that actually the results is created in the class 1. As you can see, the Nginx deployment replica is 3. And the next one, I want to show how to send a new cloud event from the hub controller. So it's very simple. So let's just. So firstly, I want to create a manifest replica set from the hub controller. I will create a new Manifestwork replica set in the hub cluster, and it will create a new, it will trigger a new cloud event sent to the work agent. As you can see, this time, it's the type of the cloud event will be different since this time we send a cloud event that wrapper multiple results. The type will be with keyword manifest bundle, and it's create request. The results version is 1 because it just created, and in the payload, it's you can see that there is a manifest list. So because we can wrapper multiple results, but in the list we just use the base box deployment, and in the agent part, it should be receive this request cloud event and send back status just like single results, but the status report type will be different according to the spec it received. So as you can see, the type is still with manifest bundle and status of the request. The results version and result ID is 1 in the spec request. And in the payload, it will be just like the Manifestwork status. We contain the conditions for the results, and also we contain the reconcile status. In the reconcile status, in the results status, we have the results meta and we have the status feedback value. Here we just return all the status from the Nginx base box deployment, and also the condition for the deployment, and we can check the cluster, check the results is actually created in the cluster. You can see that base box is created in the cluster 1. So another case I want to show is we can update this request. Here I want to update the replica from 1 to 2. You can see, and then the hub controller will send a new event to the work agent. This time to be, this one, as you can see, the new event is sent and the results version is added by 1 and the replica is changed to 2. And in the work agent, it will receive this event and finally send back the result status back to the hub controller. And you can see the type is still manifest bundle, status update request, and the results version is changed to 2. And in the status feedback, as you can see, the available replica is changed to 2. And we can also check the cluster 1, the base box deployment is changed to 2. And we can also delete the results from the user cloud event. Here we just specify the delete flag, and the hub controller will send a new cloud event. In this time, the cloud event, as you can see in the extension part, the deletion timestamp is added. It means that once the agent receives this event, it means that hub sounds want to delete this event from cluster. And the work agent will trigger the deleting step. As you can see, the deleting work has been done. And also in the upside, once it will receive the deleting status feedback, it will clear some cache in the hub side. And if we check the results from the cluster one, as you can see, the build box has been deleted. So consider that the time is limited, so it's up, and I will not show the spec reseq and status reseq. So I will leave some time for the QA. So do you have any question for this?
I think we can have more time next community meetings to discuss in more details, right, Qjang? Qjang, do you want to give like a quick feedback? I think that was a pretty awesome demo and presentation by Wei Liu.
Yeah, I think maybe next time we can have more detailed discussion about. I think some opportunity that we could think I could think of, like, because we have the Argo CD pool integration. If this is done, we probably could also use this way to pull the manifest to the managed cluster. Another thing that I think we still need to add to the enhancement proposal is about some principle about authorization. Maybe next time we can discuss more about that. Thank you.
Got it. Sounds great. So we're a little bit over. Anyone with any last minute questions, comments?
Okay.
If not, thank you everyone for attending. Have a great day. Take care.
Okay, thank you. Bye.
Thank you.